Welcome to this continuation of Chapter 1's coverage of molecules and numbers. In this video, I'm going to teach you about chemical versus physical change, precision versus accuracy, SI units, and temperature. A lot to cover, so let's get started. So, in this class, my freshman general chemistry class, for which I've made these videos, we will focus on three specific physical states of matter: gas, liquid, and solid. Now, as it turns out, there do exist more advanced physical states than these three, but I will ignore them in my main content line, though we may address them just for fun later on in class if you choose. With that said, here's a quick story. A few years back, I went to a public science museum in Philadelphia with another professor friend of mine, and we saw on a list of different activities to do this scheduled demonstration of different states of matter: liquid, solid, and gas. My professor and I are both chemists, so we're really into this stuff, and we thought, that would be awesome, let's go. We went and they brought us this large atrium demonstration area, and the presenter had everyone sit down on our bums on the floor. Now, I didn't realize it when we'd first planned on going, but it turns out this demonstration was for children. Anyway, my friend and I were kind of sitting on our bums on the middle of the floor in this atrium, and we ended up being surrounded by other people gathering, and all of them were kids. So there's a bunch of kids sitting all around us and the two professors in the middle. It was wild. But I'll never forget what the presenter said. She told us the following: that at a molecular level, if you could zoom in and look at a solid really, really closely, the individual building blocks of the solid, or molecules or atoms, look like this. They do move, but they move ever so slightly. In contrast, individual building blocks, molecules, or atoms of a liquid move a little bit more vigorously as they flow around, and then gas molecules move like this. Whoa! All over the place, right? So again, solids are like this, liquids are like this, and gas molecules are whoa! Like that. That explains the differences in density. Solids are very dense because they're very tightly packed. Liquids are somewhere kind of in the middle, hence their ability to flow liquidly, and gases are just kind of spastic all over the place. Woo! I did ask her, by the way, for permission to use that, and she said yes. With that background, then, we now move on to chemical versus physical change. So physical change is any change in which a substance's physical state or appearance changes, but its chemical formula does not. An example of this is melting water or dissolving table salt in water. The formulas, that is the chemical formulas, the atoms there, don't change. In other words, if you take solid water, that is ice, it has a chemical formula of H2O. Each individual building block or molecule inside that ice is H2O. After you melt it, it's now a liquid, but guess what? Each individual building block or molecule is still H2O. The chemical formula before doing the melting and after doing the melting is exactly the same. Therefore, you haven't undergone any chemical changes, just a physical change. So physical changes that we typically see are changing from physical state, from solid to liquid to gas, or reverse of any of those. So boiling, melting, condensing, and freezing. Make sense? Good. Now this contrasts with a chemical change. This is a change in which a substance's chemical formula is altered. In other words, the formula of the atom's bonding arrangements is different before the change than it is after the change. An example of this includes copper reacting with nitric acid, or H2O separating into H2 and O2 gases. Here's a quick video of that. If you take copper metal, which has a formula of Cu, that is the elemental formula of copper, and you react it with nitric acid, which has a formula of HNO3, it actually undergoes a change in which the copper metal turns into a completely different substance with a different chemical formula, copper nitrate over here. And it has a totally different physical appearance. Again, because the formula of what you started with and what you ended with before and after the change is different. This means that this is a chemical change, not just a physical change like melting or boiling or freezing or condensing. Similar is H2O separating into H2 and O2 gases. Yes, H2O has hydrogens and oxygens in it, but if you pass an electric current through H2O or liquid water, you can get it to separate out into H2 gas and O2 gas. Those two gases are completely separate molecules in which the bonding arrangements of the atoms are totally different. The chemical formula are different before and after the change. Ergo, it is a chemical change, not just a physical change. To sum up then, a physical change is a change in which the chemical formula is the same both before and after the change, and a chemical change is one where the chemical formula is different before and after the change. Make sense? Good.